So today we'll be talking about a new concept which is ping utility. Have you ever heard of ping utility? Do you know what this is? Any ideas?
No, sir. Is it like an instant messaging? Instant.
I think it's to check the latency, mostly
Mhm.
the data packets.
Okay, checking latency, data packets, nothing else. It's not for instant messaging. Okay, I'll tell you. So let's consider you have a friend who lives next door. He's your neighbor. Okay. You knock his door, he opens it. So now what did you learn? Did you learn what he was doing inside? No. Did you learn what TV he owns? Absolutely not. Did you learn what food he was eating? No. You learned only one thing, that he is reachable. He is your neighbor, you knock the door, he opens it. So you understand that he is reachable. This is exactly what ping will do. Ping will knock on computers, like another computer door, and if that computer replies, it is reachable. If it doesn't, either it is not there, or it doesn't want to answer, or something is blocking your message. Something in between is trying to block your message. So can ping tell us whether a website is hacked? No. Ping only tells us whether a host responds to the message that you have sent. Okay. So what is ping? Ping is a network utility. Utility as in it's like a tool. There are multiple tools included in this utility. Ping is one of them. So ping is a network utility which is used to check whether one device can communicate with another device over a IP network. Okay, remember I'm telling it IP network, not MAC network. IP network. So what it is going to help us with? It is going to help us check the connectivity. It is going to help us with response time. If I am knocking your door and you open that door after 2 hours, something is wrong, right? Between the network. You don't get instant reply. There is a latency. Latency means a delay. There can be packet loss. For example, I'm keeping myself on mute and I'm trying to talk. So I am delivering the data, I'm trying to speak, but that data is never reaching to you. Definitely there is some voice drops or packet loss. that the receiving end is not getting those packets. That can also be the issue. How is your network health? Basic network health. It is going to help you find all these issues. Therefore, we use a utility called ping. Okay, I'll write it here. Helps you with connectivity, connectivity check. Okay, it can help you with a response time, or you can call it latency. Can help you with identifying packet loss and basic troubleshooting or network health. That is what it does. Now imagine shouting hello and someone replies to that hello. If I shout hello here, someone will reply, right? Yes, sir, I'm here. So that communication exists. Consider we start the session and I'm shouting hello, good morning everyone. Am I audible? And no one is replying to it. So if no one is replying to it, it means either you guys are not on your place, nobody is there, you ignored me, my voice never reached you, or something is blocking my voice. Ping works exactly the same way. Okay. Now the question arises, where does ping get its name from? It's an interesting name, right? Ping. So this is a fun fact to remember. This ping has got its name from submarine sonar. Do you know sonar? Sonar waves, sound waves, which are used in submarine?
Yes. Yeah.
Yes. So submarine sends a sound wave which is called as ping. If it come back, like when you send it and if you receive something back, they know something is there. Computers, they do exactly the same. They'll send a packet. If it comes back, the destination will exist. So always remember where this name comes from. It's coming from submarine sound wave, which is called ping. Now what happens internally is when you try to send a message, imagine your laptop wants to ping something like a website or maybe someone's computer to check the connectivity. You type ping google.com. What exactly happens at the back end? First question, does your computer know the Google IP address?
No.
Because we know communication takes place on IP addresses, right? Do you know the concept of DNS?
It changes it gives a proper name to an
Mhm.
IP.
It's a basic networking concept. Have you read about DNS so far? Do you know what DNS does?
Yes.
It's a
What it
domain.
does? If you don't know, make sure you read about DNS. It does name to IP conversion. Okay, because I think I have mentioned this in class that we human beings are dumb. We don't tend to remember the IP addresses, right? It's difficult for us to remember. So instead, we use names. There is a server sitting in your network architecture who's going to convert this name to a IP address at the back end. Remember that phone book example that I have given? We used to have phone books in school days or when we were young. We used to write phone numbers of our friend in front of his name. Why? Because we cannot remember everyone's phone number. Do you call each other by your phone numbers? By saving phone numbers directly? No, you call out each other by names. Even in your phone book, you have a name mentioned. You don't have just the number because you don't know whose number it is. You save it by a name, so it gets easy for you to make them a call. Same way this DNS works. Conversion from name to IP. So, does your computer know the Google's IP address by default?
No.
No. It only knows the name google.com. So what happens? DNS is going to convert them. DNS converts that google.com into something like 142.258.58.15, something like that. Now, this ping utility that you have has an IP address. Who's helping it? Your DNS. Okay, that is the first step. I'll write it here. It is first step, conversion. Now, your computer creates a special packet for this. What is a packet? Nothing but a piece of information. Okay, this packet is called as ICMP echo request. I'll write it here. Step 2, creation of packet. ICMP echo request. It's going to create a special packet called ICMP echo request. Now this is like a letter. Inside that letter it says, "Hello Google, can you hear me?" Now that packet travels from your laptop to router, router to ISP, ISP to internet, and then it goes to Google. Finally at the Google destination, www.google.com, right? So it will go to Google. It won't go to YouTube. You are sending it to Google, so it will go to you, Google. That is the step number 3. That packet is going to travel. And then once that packet is received at the Google end, what Google checks? Should I reply? Is ICMP allowed? If it is allowed, Google will send reply back to you, which is called ICMP echo reply. That yes, I heard you. Your computer will receive the reply. Now, this is your step 5. He will send the ICMP echo reply and you receive the reply. Now, during this entire process, all these steps, your computer will receive the reply at the end. Okay. Now it will calculate how long did this trip take. That becomes time. Sending a message and then receiving a reply. This complete trip, a round trip of sending this packet or message, it becomes time. Now, looking at this, what do you think what ping does? Do you think ping sends TCP or it sends UDP? What do you think?
TCP.
Okay, why so? Are you getting any acknowledgement here?
It's
Yes.
an ICMP.
Oh,
So the reply would be acknowledgement, I'm guessing.
no, it doesn't use TCP, it doesn't use UDP, it uses ICMP. This is one of the most common interview question. Does ping use TCP or UDP? Answer is not both. It will use ICMP. Note this thing down somewhere. Now, I have been talking about ICMP frequently. You have seen I have mentioned ICMP. Do you know what is ICMP? Have you heard of ICMP?
No.
Yes. Nobody asked about it. I'll quickly tell you what is ICMP. Okay, let's keep this ping aside for a moment. We'll talk about ICMP first, quickly. Now, ICMP stands for Internet Control Message Protocol. Internet Control Message Protocol. Now, suppose you send a courier to your friend. Unfortunately, your friend is out of town, his house is locked. How will you come to know that the courier wasn't delivered? Someone has sent you a message. House was locked. Address was wrong. Road was blocked. Your friend wasn't available. He was out of town. Now, without this message, you'll keep on wondering what happened, right? If you don't receive such messages, internet will have same problem. When computer is sending data to each other, sometimes some things it can go wrong. Sometimes there is a cable cut, your device which you are sending a response to or you are sending data to is not available, it's not reachable. So someone has to report that problem, right? That messenger, the one who's giving you these error messages, who's that? That is ICMP. He is a messenger. So ICMP stands for Internet Control Message Protocol. You don't need to memorize the full form of it. You need to memorize the purpose of it. It is a protocol. Protocol means some set of rules that sends message about the status of your network, the health of your network. Notice one important thing here. ICMP does not carry your data. It's not carrying your email, WhatsApp message, videos. No. It's only carrying information about network itself. It's like a notification service for the network. Let's say you're trying to call your friend, and instead of your friend answering, you hear, sorry, the number that you have dialed is currently not available. Please try again later. Is this the conversation that you want to listen? No. It's simply a message which is telling you that why your call is being failed. You listen this message, right? When you try to call someone and their phone is switched off, you get this message back. The number that you're trying to call is currently switched off. Please try again later. This is the same way ICMP works. Another example. Let's say uh, you all use Amazon, right, for online delivery. Imagine Amazon tries to deliver your package, and instead of package being delivered, you receive a message. Delivery failed because address was incorrect. Amazon is not sending that package again. It's simply informing you what exactly happened. Same way your ICMP will work. So why do we need this ICMP? What do you think? Let's say you have two computers. Computer A, I'll call it computer A. This is computer B. Okay. Normally, when computer A wants to send data to computer B, like this, everything works perfectly. Now imagine this device, which is computer B. This is turned off. Computer A wants to send data, but nothing is coming back. How will computer A know what exactly happened? Someone needs to say, right? The destination you're trying to reach is not reachable. It's unreachable. That message is being sent by ICMP. So he's like that traffic police officer. Cars are moving on the road. That police officer, he isn't driving that car. No, instead of driving the car, he's saying you things like that road is closed. Take another route. There is a traffic jam ahead. Instead of going from this route, you go from that route. ICMP will do same thing. It will not carry your information. He is not carrying your sensitive data. It is just telling you what is happening in the network. So what kind of messages does ICMP send? It can send different types of messages. First one is your echo request. This is first one, echo request. Now this is like asking something. Hello, are you there? Imagine you call your friend. You ask, can you hear me? This is like a echo request. Then you get a echo reply. Your friend might reply, yes, I can hear you. So echo request. Second one is echo reply. This is how ping command works. When you type ping google.com, your computer will send a echo request to Google, and then Google will respond to it with echo reply. If replies are received, it means that destination is reachable. The network is working. Hi Saraswati, can you hear me?
Yes.
Yes, see, she responded, right? This is how ping is working. I'm sending a echo request. She's sending me a echo reply. Okay. These are two main things. What else does ICMP do? He will check destination unreachable. Imagine you send a courier and that courier company says the address doesn't exist. This is destination unreachable. This is the next thing that ICMP does. Your computer, he will send the data. The router, he decides or he discovers, he finds out that the destination you're trying to send the data doesn't exist. So it is going to send you back destination not reachable or destination unreachable. For example, google.com exists, right? We all know Google as a company. But you type something, ping, I am eating ice cream. It might say you that the destination you're trying to reach is I'm eating ice cream. Is it getting converted into some IP address at the back end? No. The destination I'm trying to ping may not exist. So it can give me back destination unreachable. Reasons can be anything. You're typing a wrong IP address, the computer that you're trying to reach is turned off, a firewall is blocking your traffic, a network cable might be disconnected. Anything can be the reason behind it. That is destination unreachable. One more thing that ICMP does is called time exceeding. This is very interesting one, I'll tell you. Time exceeding or time exceeded. Imagine you're traveling from one city to another city. Let's say you're traveling from uh, one place like USA to Russia. There are tolls in between them. Every toll booth will say you may only cross 10 checkpoints. After crossing the 10th checkpoint, your journey automatically stops. Why? Because you are allowed, your allowed time limit is already over. Network works similarly. Every packet has something called as TTL. Okay, it's called, I'll write it here, TTL. It's called time to leave. Every packet will have it. Time to leave. Don't think of it as times in seconds. No, think of it as number of packets or number of routers the packet is allowed to pass through. Time to leave. I'll explain this concept when we have practical for this ping. So for example, if your TTL is 5, packet can cross only 5 routers. Router 1, router 2, 3, 4, 5. After that, that packet will be discarded. When you're traveling from USA to Russia, as I mentioned, you have only 10 checkpoints. What will happen after 10 checkpoints? Your journey will be completed. You cannot travel on 11th or 12th checkpoint. No, that is your TTL, time to leave. After that, what will happen? That packet will be discarded. Router will send you a ICMP message, time exceeded. So why do we have this TTL? Imagine there are two routers. Okay, this is first router, this is second router. Imagine you have two routers. Router A, imagine two routers are connected incorrectly here. Well, let's say, let me draw one more. 1, 2, and 3. Let's take it A, this is B, and this is C. Okay. Now, two routers are connected incorrectly here. Router A to B, B to C, and then back to router A. The packet will keep traveling forever without TTL. If this is the case, if it goes like this, a packet is going from A to B, B to C, and again C to A. This is a loop, right? It's going on continuously. Your packet is traveling continuously. The packet will keep on traveling forever. It will be in an infinite loop. Without TTL, internet would become overloaded because the packet is always in a travel mode. It's not dropping out. So TTL helps you prevent or helps your packets prevent entering into the endless loop. That is why we need TTL. Or else imagine the packet that you are sending on internet always keeps on traveling. It's always traveling. How much traffic will be there on the internet? Right? We don't want that. So after a point, you need to drop that packet. And who's helping you drop that packet? It's TTL. Okay. That was exceeding time and TTL. One more thing that your ICMP does. It's called redirect message. Why is it taking 1.5? Redirecting message. Now suppose you're driving to USA. You ask any traffic police officer and he says, don't take this road, it's bad. Take a highway instead of this. That's exactly what ICMP redirection does. It is going to tell your computer a better route to travel. Now this ICMP and this ping, now you know what is a ping, but very few knows that ping usually or actually uses ICMP at the back end. The process is very simple. When your computer is trying to communicate with another computer, it is going to send ICMP echo request. When it reaches the destination computer, it is going to reply with ICMP echo reply. The way I called out Saraswati, right? I send a ICMP echo request to her and she responded with me to ICMP echo reply. Have you heard of traceroute? Do you know about this term called traceroute?
No.
No. Okay. Traceroute means it's like first of all, this is a networking command. Okay, traceroute. What you type on your computer to get the exact route of where your packets are hopping or how far your destination is. That is what traceroute command does. So traceroute also uses ICMP protocol. Imagine you're traveling from USA to Russia. You want to know every city that you are passing through in this entire journey from USA to Russia. Traceroute will do the same thing. It will show you every router between you and your destination. That is what traceroute does. That is also being used by ICMP. Traceroute uses ICMP. Okay, suppose there are two destinations, like I mentioned, USA and Russia, traveling from USA to Russia. So between that you will get countries, right? You are not going to directly hop from USA to Russia. Directly you cannot reach that country, right? There will be multiple cities that you will have to pass through in order to reach. So this, which city is this? Which city is this? All this information can be carried out with the help of traceroute. Traceroute discovers these routes or these routers by sending packets with gradually increasing TTL. Each router where this TTL message expires, it is going to send you back that time exceeded, allowing your traceroute to identify that hop. It's just number of hops that you are taking from source to destination. That is what traceroute does. Okay. Now this entire conversation which we had from first point to whatever ICMP thing that you have learned, what do you think, where will this ICMP sit? In which layer of OSI model?
Transport layer.
Transport layer. You sure?
But since it's a protocol, it uses the network.
Network. Any other inputs? As I mentioned, all this activity is happening on basis of IP addresses. Where do you get IP addresses?
Network.
Network layer. This is closely associated with IP and it helps report problems related to IP packet delivery. It's not end-to-end delivery. It's IP packet delivery. Therefore, it is coming on network layer. If that would have been end-to-end packet delivery, it would have gone to transport layer. But all these stuffs are related to IP addresses. So this comes on network layer 3. ICMP works on network layer 3. Okay. So what are common messages that you get? ICMP echo request, echo reply, destination unreachable, time exceeding, and any redirect message. Clear what is ICMP? Yes, you want me to repeat anything here? Is ICMP concept clear to you theoretically?
It's clear, yes.
Hmm. Because we are going to now jump onto practical stuff. We are going to see some practical on this, how actually these things will work. So before moving, take 2 minutes of time, process this, and if you have any doubts, ask. Okay, we'll also jump onto practical. Okay, no doubts. We'll jump on to practicals now. If you have anything to ask, you can let me know. What I want you to do is go on terminal of your computer, or you can just type CMD. You know how to open terminals, right? If you're using Kali Linux, you can open terminal. If you're using Windows, you can open CMD. Don't go on PowerShell, okay? Open CMD. Just in that search panel, type CMD. CMD is your command prompt. Just open it.
In Kali Linux, right?
No, not necessary that you need to jump onto Kali Linux. What operating system are you using?
Windows.
Windows, right? So you have search panel, right? You know where the search panel
Yeah.
is? Yeah,
Mhm.
just type CMD there. CMD and open it.
Okay.
Okay. Just checking. I'm able to open my CMD, but I'm not able to share it. Just let me check my sharing. Yeah, here it is. Hmm. Can you see my command prompt? CMD. This is how it is opening, right? CMD, you get a black terminal, Windows people. Same things in Kali Linux. If you are operating Kali Linux, you can use terminal. Both will serve the same purpose. No confusions. Okay. Now let's just type ping google.com. Send it. Okay. What do you observe from this? You're pinging google.com, right? But at the back end, as I mentioned, DNS server, right? It's taking an IP address. This is an IP address. It's called IPv6. IPv6 address. Let's try to understand what this thing is or what it is trying to talk to us. When you type ping google.com, your computer now wants to ask Google, hello Google, are you available? Here is the first problem, that your computer doesn't understand google.com. What he understands is IP address. He doesn't understand names. So before ping can even start, something else happens. What is that something else? It's called DNS resolution. The thing that you typed here, google.com, that google.com is getting converted into an IP address. This is a resolution taking place. That is what DNS does. Windows is asking your DNS server, can you tell me the IP address of google.com? Consider your granny. She's giving you a book, that black contact book, right? That we discussed. She's not able to see without her glasses. She has misplaced it somewhere and she's asking you, hey, can you please give me my daughter's phone number looking at this book? Same thing your Google is asking to DNS server. Can you please give me IP address of google.com? And DNS is responding to him. Yes, 2404 6800 4000 1025 blah blah blah, whatever it is. This is a reply received from DNS server. Now your computer knows where that Google is. Only after getting this IP address, your ping begins. Before that, nothing happens. Okay, so now this part is clear. Now let's understand what is happening next. Okay, pinging means you're sending a ICMP echo request, as I already mentioned. So this 24046800 this is a Google's IP address. But why is it looking strange? Because this is IPv6. This is not IPv4. It's version 6 IP address. IPv4 will look something like 142.250.183.46. Whatever is the Google's IP address, it will look like that. Since my internet is supporting IPv6, Windows automatically preferred IPv6. Has anyone got any other IP address here when you type google.com? Do you see any other Google address?
Yeah, different from yours, yes.
Yes, definitely. What is the IP address that you're getting? Is it IPv4 or IPv6?
How can I tell that? It's 2607 F8 B 04023
Mm-hmm.
100B 71.
Okay, so if it's only numbers, it means it is IPv4. If it is separated by um, dot dot three dots, and there are four terms, for example 123 dot 456 789, whatever it is, something like this. If it is in a four part 1 2 3 4, it is IPv4. If it goes beyond that, or if you see any numerical values, sorry, in any alphabetical values, A, B, C, D, E, or F, that is IPv6. So right now you're getting a different IP address. Okay, that's completely fine. Everyone will get a different address because Google is having multiple servers, right? I'm operating from a different place. You guys are operating from a different place. We are trying to reach a destination. So is Google having only one server to respond? No. Google is having multiple servers to respond in each region. I might be getting reach from a different server. You might be getting reach from a different server. So our IP addresses are different. Depends. But are you getting a reply? Yes.
Yeah.
You're getting a reply after pinging it?
Mm-hmm.
Yes, that is important. Okay. So even your computer is supporting IPv6. So you are getting a response to that. Okay. Let me quickly connect my charger. Okay. Hmm. Now, do you know the concept of IPv6, IPv4?
Yes.
Let, why was there a need of IPv6? Can anyone tell me?
Does it work with the updated version of the computer?
No.
I think they're running out of IPv4 and IPv6 have
Uh-huh.
more numbers.
Correct. Now, IPv4 is going on since long time. Okay. But eventually there was or there is a digitalization, right? Everything is going digital. First, we had only one mobile phone or one telephone at our home. Now everyone in our home has a mobile phone. Your daughters, your son, your grandparents, your husband, your wife, your driver. And it's not only one device. You might have two devices. I have three laptops, one mobile. And every device is going to need an IP address, right? Was IPv4 able to handle so many IP addresses? No. We eventually evolved with multiple devices coming up, right? 3344, 10 devices, your smartphones, your smart computers, your smart TVs, everything is working on IP addresses. So after a point, there was a need for an upgrade because IPv4 was getting depleted. There was limited IP addresses in IPv4. So we moved from IPv4 to newer version, which is called IPv6. So there is a possibility that sometimes you will get IPv4 address, sometimes it will be IPv6 address. We are not completely moved from IPv4 to IPv6. That migration is still under process. Therefore, there is a high possibility that some of you will see IPv4 address, some of you will see IPv6. Completely fine. Okay. Now let's understand what is this 32 bytes of data. This is another common question. What does it mean? Your computer sends a small ICMP packet. Okay. Inside that packet, Windows places 32 bytes of data. Think of it like a tiny message. Not because your Google is needing it, no. Because your Windows wants to test whether the data can travel successfully. So if you're asking Google, can you hear me? Or if I'm saying hello to you, can you hear me? That hello message is 32 bytes. Okay, that is the size of your packet, 32 bytes. Question arises, can I reduce this packet size? What do you think? What do you think? Can I reduce this packet size from 32?
Probably yes.
Maybe yes. Answer is absolutely yes. You can do that. All you have to do is type ping again google.com. Instead, I'll do -L in lowercase, okay, on Windows and type 16. Can you see? It's still sending packets, but now with 16 bytes of data. I can do that. I can change that number.
So
So
what is the difference?
nothing, the packet size.
It's only the size. Okay.
Yeah, size of packets. Can you make it 64? Can you make it 128? Of course you can do that. Can you make it 512? Of course you can do that. All you have to do is type -L in front of it and set the byte. It's nothing but the size of your packet. And why would anyone change this size? Why are we trying to change this size? To check the network reliability. That's it. If small packets would work, but large packet would fail, what does this indicate? There might be some issue with the fragmentation. Or maximum, your network can carry only 32 bytes of packets. Therefore, it is failing. It's just checking the capacity.
For me, I'm getting an error.
So it's not capable of doing that.
Yeah, it says cannot set preload to value greater than 3:16.
Hmm. So your network is not capable of sending a different packet size. Did you do 16 or greater than 32?
I did 16.
16. Huh. So maybe your network is not supporting that packet. What is the error that you are getting?
It says cannot set preload to value greater than 3:16.
Can you just copy paste that in the chat here?
I tried doing that, but it didn't copy and paste. Let me try that again. I should be able to. Yeah, it's just copying something else.
Okay.
That is weird. Yeah, let me try.
Sure. Okay, you can paste it in the chat.
Yeah.
Meantime, we'll
For some
continue.
reason, it's not
Okay.
copying. Yeah,
Not a problem. Meantime, we'll continue. If you're able to do that, just paste it in chat. We'll see what that error was. Okay.
sure.
Yeah. so that we can now change the number of bytes there. Okay, from 32. Let's jump on to the next part. We have so far we have seen what this is. Okay, 32 bytes of data. This line we have seen. Now let's jump on to the reply section. Let's understand what this output is. Okay, now since you pinged, you ask Google, are you there? Google is responding to you correctly, right? Now after that, the first reply that you are getting, and it has a time in front of it, right? What is the time mentioned? 39 millisecond. MS means milliseconds here. This is the first thing. First reply took 39. Let's try to decode this thing. Google answered to you. He sent a echo request. You send a echo request to Google and he replied you back with echo reply. So the conversation looked like this. You tried to ping Google with echo request. Google is responding you with echo reply. The time taken in this entire process was 39 milliseconds. This is extremely important to understand because the complete journey took 39 milliseconds. Notice something, it is not just the time to reach Google, it is the complete round trip. It's called RTT. From your device to Google and from Google back to your device. This complete round trip, 39 milliseconds. Okay, it's called round trip. Now what is 39 ms here? It's called millisecond. 1 second means how many milliseconds? Basic mathematics. It's 1000 milliseconds. Okay, 1 second means 1000 milliseconds. So 39 milliseconds means how many seconds? 0.039 seconds. Like fraction of seconds. Less than 1/20th of a second. In short, it's very fast. Let's not go to mathematics. Okay, let's jump on to the next reply. 43 milliseconds. Another ICMP packet which took 43 milliseconds. A third ICMP packet took 42 milliseconds. Sorry, third one 42. Last one 47 milliseconds. Okay. And why are you getting different times here? Because your internet is dynamic. Sometimes packets can take different routes. Sometimes routers are busy. Sometimes network traffic is lower. Sometimes it is higher. So packet doesn't necessarily take exact same amount of time every single round trip. It can differ. Sometimes it will be faster. Sometimes it will be slower. Why are this time different? Because let's say you're traveling from one place to another. Let's say you're traveling from your home to your college. Sometimes you might take 30 minutes to reach. Sometimes it's 45 minutes. Sometimes it's 35 minutes. Is it exact same time that you reach from your home to your college? Exact same time every single day? No, not possible. Is the distance changing? No. What is changing? Traffic. Therefore, you might get different values due to network congestion. It changes continuously. Okay. Clear so far on these points? Whatever I have said so far?
Yes.
Yes. What about others? Are you getting it?
Yes.
Okay. All right. Now let's understand what these statistics are. Okay, these are important points. Ping statistics. Now Windows is summarizing everything here for you. Look at this thing, number of packet sends. How many number of packet we have sent? 4. How many packets have we received? 4. And what is the lost packet percentage? It's 0. Okay, it means your computer asked Google, are you there? 4 times. And Google responded 4 times to you. All 4 times he responded. It means you have excellent connectivity. Imagine you're calling out your friend, or I'm trying to call out Saraswati. Saraswati, 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 Saraswati. And she's responding only 1 time. Is there a good connectivity? No. When she's responding all 4 times, there is an excellent connectivity. There is a possibility you're trying to reach out someone for 4 times, and out of which only 2 times is reached. What do you think will be the failed percentage? Yes, come on, basic maths. 50%. Half of the message was reached, half of the message was not reached.
In this
If
case, sir, we gave one, like, why does it say send 4 times if we type just once, pinggoogle.com?
that is the way it works.
Okay.
Because if you're sending 4 packets, you get a better, how do I frame it? Like a better resolution or troubleshooting ways by sending 4 packets. If some of the packets are not received, you immediately get change in that lost percentage. Okay,
So it is different for different websites.
means
Is the number of packets, like if we would ping Amazon.com, that would
mhm,
be different number of packets, right?
mhm. So let's say no, that will be 4 packets only every single time.
Okay, okay. So
Mm.
this is standard, 4 packets every
Mhm.
time.
Yeah,
Oh,
yeah. So if you're asking like why are we not sending only 1 packet instead of 1 packet? That is your question, right?
right.
Right. So for example, you're trying to send only 1 packet, okay, and that packet is lost. Does that mean Google is down?
Yeah,
Maybe
makes
your
sense.
Wi-Fi can have a glitch. Maybe your router just dropped the packet. Maybe there was some congestion in between.
But
So 1 packet is not enough to judge the health of your network, right?
mm,
Why 4 packets? Because there is no specific mathematics behind it. It
yes.
is a default behavior of your Windows ping command.
Mm,
Microsoft choose 4 packets because it gives you a quick, um, you know, quick way, or it's like a sample of connection. Like without creating unnecessary traffic, you can send 4
mhm.
packets, and 4 packets can easily calculate packet loss or minimum maximum response time. Therefore, they are sending 4 packets.
Okay, that makes sense. Thank you.
Yeah. All right. Where were we? Number of packets sent, number of packets received, and 0. So all the 4 packets which you have sent has reached the destination and you are getting a response back from it. Okay. So there is 0% loss. This is one of the most important indicator of your network health. 0% loss. Imagine you're trying to send a message to your friend on WhatsApp. You're trying to send, I will kill you someday. and only message that is getting delivered is I will kill you. Someday, unfortunately, was the last message which did not get delivered. What will happen? Your friend will think, okay, he's going to kill me, she's going to kill me. All the messages got reached except one. There was a packet loss. Here 0% packet loss means what? All the four reached your friend. No problems at all. You sent two. Now imagine only two are received. Two are failed means what? There is 50% packet loss. Now why this issue can occur? This will indicate you that there is something wrong with your Wi-Fi. It can be a weak signal, maybe bad internet, network congestion. Sometimes your cable can be faulty. Your firewall is dropping some ICMP packets. There is too much load on your router. It can happen, right? Therefore, these percentages can change. All right. Now let's jump on to the next line, which says approximate round trip in milliseconds. It says 39, 47, and 42. Minimum, maximum, and average. Windows now calculates your connection speed. What is minimum? Minimum we have 39 milliseconds. This was my fastest reply if you see 39 milliseconds. Among this was the fastest one, right? What was the maximum one? 47, 47. Maximum time, minimum time. And average, average means sum of or 4 divided by 4, whatever it is. That's mathematics behind it. Average of all 4 responses. It's like calculating your average marks. So do you think 47 is an excellent speed here? Answer is no. When your reply is between 0 to 20, has anyone got a reply time between 0 to 20 milliseconds?
Yeah, I have under 10.
Yeah, that means you have excellent quality of network. If it is between 0 to 20, it's excellent. 20 to 50 means very good. Has anyone got it about 200 or maybe above 500?
I have a average of 218.
Yeah, it's a poor network.
Really poor. Yeah.
So 100 to 200 is somewhere acceptable. Above 200 is poor. Above 500 is pathetic. Very poor.
So does this calculate the speed of the internet or the device itself?
No, it's calculating the time taken by your device to reach the website you are trying to reach.
So it means how slow or fast or the health of the devices, right?
Hmm.
Okay.
So there can be issue with the network that you are using, or sometimes it can be issue with the Google server that you are trying to reach. We all are trying to reach different Google servers. If you see, we are getting different IP addresses, right?
Mhm.
DNS is resolving it to a different IP address. So maybe when you try to reach some other website, you can try youtube.com maybe if you want. If you see that your response time is gradually decreasing, there is no issue with your internet. Maybe that is the issue with the Google. Therefore, it was giving you more than 200 milliseconds, right? So it's not your problem. It might be Google's problem. Depends, right? That is what this reply says. Is this complete reply clear to you? Any doubts so far?
No doubts.
Okay. So for example, when you get time as 450 milliseconds, or sometimes it exceeds 500, there is a rare case scenario that it exceeds 500 or something like that. Sometimes, when you're traveling from your home to school or college somewhere, there is a road construction going on, or maybe there is an accident. So depends on the traffic. Sometimes you might take 20 minutes, sometimes it can take 1 hour. Destination is not changing. Road is not going anywhere. It's simply the traffic, the network congestion that you might face a problem with. Okay. So when you're trying to reach any server which is far, far away from you, that time you will see that this time taken 39, 43, 42, 47, this will also gradually increase. Right now, this Google server which I am trying to ping, this is the nearest to me. Therefore, I'm getting minimum time. When I'm deliberately trying to reach a server which is far away from me, countries away from me, it will take more number of hops to reach that destination, right? To For the packet to travel and then receive it back. That time this number will gradually increase. Simple as that. Clear? Any doubts in understanding ping?
Just one question. So when we are trying to
Yeah.
reduce the size of the packets, right, from 32 to
Mhm,
16, so that is
mhm.
just trying to reduce the payload, right? Anything else than that?
No, nothing else.
Okay.
It's just the size of packet that you are trying to send. By default, it is 32 bytes.
Okay. Yeah.
Okay.
Thanks.
Yeah. All right. Just play with it. Maybe this is, you might have used it somewhere. Is it the first time that you are learning ping? Anyone? Was it your first time understanding or learning ping?
Yes, first time
First
learning.
time. Mhm. Now, do you understand what is ICMP, what role it plays, what is ping helping you with?
Yeah.
Yes.
Yes.
Play with it. If you have any doubts, don't just try to ping google.com. Maybe try to ping some IP addresses that you know. Maybe your um, same network IP address, or maybe your mobile's IP address. You can try any other website if you want. Try playing with it. It's more of a troubleshooting tool. It's like a utility. It's going to help you a lot understanding these concepts better.
So you mentioned about DNS resolution. So does that happen
Mhm.
when we try to do ping and the number, like let's say like 8.8.8.8?
Why will it require a DNS resolution in that case? If it knows that IP address, what is happening exactly when you try to call any number? Let's say you know your friend's number. Okay, you have by heart that number, you already know it. So instead of going and typing or searching his name, you directly type number, right? And you make a call. You know definitely that this is going to reach the correct destination. In that case, you don't need to refer to DNS. But when you're typing even that number, that IP address, he will check in DNS first, right? What address it is going to refer. Is your computer knowing that thing, that okay, you have to call your friend? No. He will check in his phone book. Who's that phone book? It's DNS server. So irrespective of anything, it will go to DNS server. It will check, okay, this belongs to 8.8.8.8. Oh, this belongs to Google. Send him to Google. That is what it will do, right? And I believe you have sent the message here, right? What was that error message, right? Error from earlier. Kali desktop ping Google hyphen L6. Okay, you're using Kali Linux here. All
Yes.
right. Can you try hyphen S instead of hyphen L?
Okay, let me
Check
try.
if you're getting that error.
It's working.
It's working, right? So this is the operating system. I believe even Mac operators or Mac devices will also require hyphen S instead of hyphen L. Hyphen L is for Windows. Hyphen S is for Linux or your Unix systems. Anyone Mac users here?
Yeah, I use Mac.
What works for you? Is it hyphen L or hyphen S?
S.
S, right?
Yeah.
Mm. Because on Kali Linux, hyphen L means something else. Windows hyphen L means that's the packet size, the payload size that you are sending. On Kali, it means preload. Sometimes multiple packets are sent before waiting for replies. So that value changes. So hyphen L, hyphen S have different meanings on different operating system. Nothing else. So the error that you are getting, that 6316 3:16, that basically means you are trying to preload 16 packets, which is not allowed. It's not you're sending 4 packets, it's you're preloading 16 packets. Therefore, you're getting this error. And because it has a different meaning on that operating system. Hyphen S will perfectly work fine for you. Okay. So if any doubts, let me know. If nothing, you can wind up.
Actually, one question. Like
Yeah.
when I try to do like ping Amazon.com, it's just giving
Mm-hmm.
me error saying like request timeout, and none
Mm-hmm.
of the packets has been sent. I just want to know why. I tried like a couple of different other stuff, but it's working except like Amazon.com.
Mm-hmm.
Can you try and
Why are
see?
you getting? Should I try Amazon.com?
Yeah,
Wait.
please.
Okay.
I try to reduce the bits as well in
No,
16, but
bits
still the same.
reducing this won't help.
Okay.
This 32 bytes won't help you. This is just the
Okay.
size of packets. What is the
Okay.
problem? The destination. That is the problem. Let's see. Let's try to figure it out. Okay. Lost 4 packets, sent four
Yeah.
packets. All right. Let's see what exactly is happening here. Now we have tried to ping 98, 87, 170. Let me try one thing. Do you see the difference?
Okay, so I have to add like a www dot. So why is that like for Amazon.com we have to add, whereas like when I try to do like a Walmart or like Google.com, I don't have to.
Mhm. See, what is happening is your DNS is working perfectly fine here. If you see your DNS server, he tried to convert that Amazon.com into an IP address, right? He first contacted the DNS server, which technically converted it to 97.87.177, right? Something like that.
Mhm.
So your DNS is working properly. That is the one thing you should understand from this ping. Okay.
Okay,
If DNS would have failed, you would have got some other error message like ping could not find Amazon.com or something like that. So
okay,
the first part of your communication was completely successful here.
okay.
Second thing was your ICMP echo request. Your computer then sent ICMP echo request to 98.87.170.7, right? You might have different IP address. Do you have different IP address or is it same?
No, actually I have the same one.
Same one. Okay, that's fine. So what is happening here? You are saying, hello Amazon, are you there? Right? And you're
Mhm.
waiting for a reply. Your computer waited for an ICMP echo reply. Normally you would expect a reply from it. But what you are getting? Request timeout 4 times.
Right.
Does this mean Amazon is down? No. You can open Amazon. Can you open Amazon.com in your browser right now?
Mhm.
Just try. Answer would be yes. You will definitely be able to open it. Amazon.com. So if that website is opening and your ping is failing, what is happening here?
Yeah, I can open it.
You can open it, right? What
Yeah.
is happening here is, this is very interesting. Companies, large companies, big MNCs, they usually block your MNC, or they block your ICMP ping request deliberately. Because think about Amazon. Thousands, not thousands, lakhs, millions, billions of users are using Amazon every day, right? If
Right.
everyone, they try to send ping request every single second, what will happen?
Is it the denial of services?
Correct. Amazon services or Amazon servers, they are wasting their resources replying to such dumb messages, right? We are just trying to test at our end, right? But
Mm-hmm.
it is responsibility of Amazon server to respond you back, right?
Right.
He's getting your request, he'll process it and then he'll respond you back. So unnecessary, we are using Amazon resources, right?
Mm.
So Amazon is simply trying to ignore your ping request. Therefore, you are getting messages here,
Okay. Gotcha. Got it.
right?
Thank you.
So usually companies, they have this mechanism uh, to block ICMP messages. When we will learn about a tool which is called Wireshark, I am going to teach you about Wireshark tool. So that time I'll show you, when you try to ping, actually you will see ICMP echo request and ICMP echo reply being sent and received on the protocol side.
Okay.
Okay, clear on that part?
Yes, I am. Thank you.
Yes. All right. So that's all for today. We will, if possible, see few more interesting things. I'll try to collect few more interesting things that I can give you about maybe ping. We are out of time today, maybe 5-10 minutes tomorrow, and then we'll start with a new topic tomorrow. Okay,
Sounds
that's all for
again.
today. If you have any doubts, feel free to ask anytime in the session tomorrow. Okay, try it. Thanks for joining. See you tomorrow.
Thank
Thank
you.
you.
Thank you. Bye.